limit as z goes to -1 of the square root of z plus 7 minus the square root of z squared minus 5 times z divided by 4z squared minus 5z minus 9. The first thing we're going to do is try plugging a -1 in for each of the z's. That will give us -1 plus 7 under a root minus a -1 squared minus 5 times -1 under a root divided by 4 times -1 squared minus 5 times a -1 and then minus 9. In the numerator, -1 plus 7 is a 6 minus what will be a -1 squared, which is 1, and a -5 times a -1 is a positive 5. In the denominator, -1 squared is a 1 times a 4. -5 times -1 is a positive 5. And then minus 9. In the numerator, we have root 6 minus the root of 1 plus 5, which is 6. In the denominator, 4 plus 5 is a 9. And then minus 9. In the numerator, root 6 minus root 6 is 0. In the denominator, 9 minus 9 is 0. We have the 0 over 0 indeterminate form. We will need to rework this since we have a root combination, a root involving the variable z in some way, added or subtracted together with at least one other term that's happening in the numerator. Both of them are roots. Both of them involve z. But we still have a root conjugate, and we can do the root conjugate method. So I'm going to rewrite the limit exactly as we see it. And we're going to multiply by the conjugate, which is the same expression but opposite sign between the roots. And we'll multiply the denominator by the same root conjugate so that we have a form of 1. And we don't change the value, just the look. In the numerator, we have the root conjugate pair. We're going to FOIL that out. First, root of z plus 7 times root of z plus 7 is z plus 7. Outside, root of z plus 7 times the positive root of z squared minus 5z will be the positive root of z plus 7 times z squared minus 5z. Inside, negative root of z squared minus 5z times the positive root of z plus 7 will be negative root of z squared minus 5z times z plus 7. And then last, we have the negative root of z squared minus 5z times the positive root of z squared minus 5z, which is going to be minus of the quantity of z squared minus 5z. Be careful, put that into parentheses, and we're going to be distributing that negative sign in. Now, after you FOIL out a root conjugate, the outside and inside terms should always cancel. Let's cancel those out. In the denominator, we do not have a root conjugate pair, so we are not going to FOIL it out. We're going to have them multiplying each other in a factored form. The next step is to distribute the negative sign in the numerator onto this expression here. So let's do that. Limit as z goes to -1 of z plus 7 minus z squared plus 5z divided by that denominator we're just going to leave alone, 4z squared minus 5z minus 9 times the square root of z plus 7 plus the square root of z squared minus 5z. In the numerator, we can combine together like terms, and that will give us limit as z goes to -1 of negative z squared plus 1z plus 5z is plus 6z, and then plus 7 divided by the denominator. So we've taken care of the root conjugate multiplication, and what that always does is changes it to a new form that is still 0 over 0 but can have other work done with it. In this case, these are power functions, so we can look to factor cancel. Z going to -1, if you plug -1 in for the z's, it will make a 0 here and it will make a 0 here. But those do not cancel as we see them. We have to factor them. Since z is going to -1, I expect a z plus 1 factor in both the numerator and denominator. Since the numerator has a negative z squared for its leading term, I'm going to start by factoring a negative out, which will give us a positive z squared, a negative 6z, and a negative 7. Change the sign on everything there. I'll just make it a little easier for the factorization. Leave everything else exactly as we see it. So we have limit as z goes to -1 of this numerator, can trinomial factor. Remember, we expect to see a z plus 1 as one of its factors, so we'll watch to see if that's the case. But we need two numbers to multiply to be a -7 and add to be a -6. So it sounds like -7 and +1 will take care of that for us. In the denominator, we also need to trinomial factor that expression in some way. And we have the roots that just come along. All right, so we have 4z squared, so we can have either 4z and 1z, or 2z and 2z. Let's try 4z and 1z first, so 4z and 1z. And we need two numbers that multiply to be a -9, so one will be positive, one will be negative. And they can either be a 9 and a 1, or a 3 and a 3, and we just have to try the different combinations. So say we try the 3 and the 3. You could plug a 3 here, you can plug a 3 here. This will be a 12, and this will be a 3. And a 12 and a 3 can in no way give us a 5 that we should see in the middle, so it doesn't look like the 3 and the 3 work. At least not with the 4 and the 1. Now we might also have 2z and 2z, that's another option. But the 9 can be a 9 and a 1 as well, so we'll try maybe a 9 and a 1. And well, that's 36z, and that's 1z. That will in no way add to a -5. But because the 1 and the 9 are not the same number like the 3 and the 3 were, you could reverse where you put them, and maybe the 9 here and the 1 here. And that will give us a 4z and a 9z, and a 9 and a 4 can give us a -5 if the 9 is negative and the 1 is positive. So we have a -9z and a positive 4z. So we have factored it. And no surprise there, we're getting a z plus 1 as one of our factors. That was expected. Those can now cancel. And we should no longer have the 0 over 0 indeterminate form, and we should be able to plug in a -1 for each of the z's. Let's just rewrite everything we have. So in the numerator, that will give us a negative of -1 minus 7. In the denominator, we will have 4 times -1 minus 9 times the root of -1 plus 7 plus the root of -1 squared minus 5 times -1. In the numerator, -1 minus 7 is a -8. In the denominator, 4 times a negative 1 is a negative 4 minus the 9 times the root of negative 1 plus 7 is a 6 plus the root of negative 1 squared is a 1, and then a negative 5 times a negative 1 is a positive 5. So we're getting in the numerator, double negative, so positive 8. In the denominator, negative 4 minus 9 is a negative 13. And that'll be multiplying root 6 plus root 6. So we have an 8 divided by negative 13 times 2 root 6. Since everything is multiplying in the denominator, that 8 and that 2 can cancel, leaving a 4 in the numerator. So we end up with negative 4 divided by 13 square root of 6. This can be rationalized if we wish, and maybe I will show the rationalization. That's where we multiply the numerator and denominator by the root, which we see in the denominator, which is root 6. That will give us negative 4 root 6 divided by 13 times 6. And this can reduce a little bit because the 4 and the 6 here can reduce by a 2, leaving a 2 in the numerator and a 3 in the denominator. So we can also write this as negative 2 root 6 divided by 13 times 3, which is a 39, is a optional result for this.